Hello and welcome to the episode 5 of PyTorch Code Deep Dive. In the second episode, I showed how default iterating over the DataLoader works. Such default iterating is using the same process as a DataLoader. In this episode, I will show how multiprocessing is used when multiple workers are specified. It's the main reason why multiple workers speeds up data loading considerably. I'm still using same example as in previous episodes. This time I will set number of workers to 2. Let's deep dive to see what happens. Firstly, iterator is created, and since we don't use persistent workers, iterator is created directly. There's additional check that checks workers' rationality. PyTorch checks if requested number of workers makes sense in regard to available CPU resources. In this case, CPU scheduler affinity function is available and it equals to maximum number of hyperthreads in my system. If I requested more than 24 workers, Torch would issue a warning, but this time it's not the case. This time, it's multiprocessing DataLoader iterator. As before, it copies properties from DataLoader. We use default prefetch factor of 2 and in order flag is set to true. There are also sanity asserts about past values. Default multiprocessing context is related to Torch module. It contains a set of functions that specifies things like sharing strategy or thread names to be used. Worker initialization is none by default. Iterator creates worker result queue object. As the name suggests, this queue is used to retrieve results from the workers. The class of the queue refers to Torch module, however eventually it comes from standard Python multiprocessing module. Let's put this on a diagram. Worker pits, set and shutdown are lifecycle flags. There's also workers done event object created. Now, for each worker, communication queue is created. This queue is used to submit indexes to workers. Each worker is represented by the process that will start with worker loop function. I will set up breakpoint here as it will be useful in the future. Worker loop function uses a few arguments that are related to data fetching and communication, including index queue, dataset, and worker index, and common parameters like number of workers in DataLoader. The created process is a daemon, so it should be terminated when DataLoader process ends. Once the process is started, both queue and workers are stored in iterator lists. Let's put it on the diagram. There's one result queue and multiple index queue, one per each worker. Loop iterates twice. Since we are not pinning memory, data queue equals results queue. On persistent workers and pinned memory, additionally, cleanup is performed on exit. There are additional functions that register worker PIDs and signal handler. As these are native ones, I'm not going to show what's inside. On iterator create, it's being reset. Let's deep dive to see what it does. Firstly, it creates batch sampler iterator. There are two indexes to track. Index of the next task to be sent and expected next index of the task to be returned. Task here means request to fetch batch of data. There's also a map that for each task tracks which worker handles it and data that it potentially returns. Iterator also tracks number of tasks that are in flight. Worker status is the last known status of worker. When false means the worker is no longer available. Worker non-tasks tells how many outstanding tasks each worker has. Worker queue index cycle is an infinite range that for two workers returns sequence like 0, 1, 0, 1, 0, and so on. Since this is a first iteration, iterator will create 4 tasks for its workers. 4, since there are 2 workers and prefetch factor is 2. We should not request more tasks when maximum of task already was requested. Next index returns the next value from batch sampler. Batch sampler works in the same process as DataLoader and returns first 8 indexes for this task. The logic in the loop is about selection of the worker first. Cycle iterator works in a round-robin fashion. We start from the worker with index 0. Since the worker is available and we requested batches in order of request, worker 0 is selected. Once worker is selected, we put indexes into the workers queue along with task index. Task info is created and bound with worker queue. Number of tasks performed by the worker as well as the number of tasks in flight and the next task index are all increased by 1. This makes complete state update about task submission. This process is performed 4 times. The important thing is that on the next iteration, the next worker of index 1 is selected. Accordingly, data related to worker 1 is modified. Also, state related to number of tasks is changed. I will show this call last time to point that during third iteration worker index is 0. This is for the worker 0 to receive second task as indicated by prefetch factor. Pay attention to distinguish that there are worker index, batch index, and task index, each of which means different thing. At this point, iterator is created, all worker processes are created, and initially 2 data requests are created per worker, so 4 in total. Let's proceed with next method. Next data runs in infinite while loop. It checks if next expected task index is smaller than next task index to be sent. Once there is no more task to send, the iteration will stop. Firstly, it's checked which worker handles the task. If task information contains data already, or there's still processing, internal loop exits. When the next check is true, iterator process retrieved data directly. In our case, iterator calls getData. GetData is trying to retrieve data from the queue directly. There's no timeout by default, therefore iterator will run infinite loop to retrieve the data. Mind that if your DataLoader process hangs, it's likely displays. Try getData asks data queue with default 5 seconds timeout. As I put breakpoint before into worker loop, we can see that it eventually triggers. I will show in a minute how the worker process works. In this particular case, no data was returned within timeout, which is why exception was generated. Workers are still alive, therefore parent getData repeats invocation on try getData fail. This time, data is already in the queue. It's retrieved as task index and our batch data. We don't have out-of-order processing, therefore we can update task state directly. Process task information is removed. Next to be received task index is increased, and the final data processing is called. We will decrease number of tasks being processed by the worker. Since number of tasks in the queues are smaller than possible maximum, we are going to create another task to keep workers busy. The next batch of indexes is created. Again, Torch relies on cyclic iterator. This time it's worker 0. Task of index 4 is created with new batch of indexes, and the whole other task state is updated. Once the final data containing batch is ready, it can be returned in the loop. In this video, I showed how DataLoader iterates when multiple workers are declared. In the part 2, I will show what happens when iteration ends and how the worker processes handle communication with DataLoader process. If you like this video, make sure to press like button and subscribe. I hope my content will help you creating something great. Thanks for watching.